Hey class, I'm Mr Thornton, and I'm going to help you succeed in your GCSE. This lesson, collision theory. This topic was requested by Danny Becker, Ijaz YouTube, Rachel Elvin, Tharasan Kanaga-Sabai, Rhodesman Zudin, and Specker. Thanks guys. If you've got a topic which you'd like me to cover, then just leave a comment below. Now, obviously, manufacturers quite often want to be able to control the rate of their reactions. Usually they want them to be able to go as fast as possible so that they can make more product in a given amount of time, which means that they can make more profit in a given amount of time. They can earn more money. Sometimes they might also want to be able to slow them down for safety, but most of the time what you're going to be looking at is manufacturers who want to speed things up. And this brings us on to the idea of collision theory. Collision theory is all about the idea that if we want two particles from two chemicals to be able to react with each other, they've got to meet. They've got to bump into each other. If they're both in the same beaker, but they're at opposite ends of the beaker, then there's no way that they're going to react. They have to bump into each other. And that's all that collision theory is. It's the idea of how can we control the process of these two particles bumping into each other. Normally, how can we speed up the process of these two particles bumping into each other? That can be a little bit abstract because we can't see the particles themselves. They're normally going to be way too tiny for us to see. But it's pretty easy to understand if we think of it by analogy, because it's a little bit like trying to increase your chances of finding a date. Who knew that chemistry would actually relate to relationship advice as well? So remember in our analogy, people are particles. One of the best ways to increase your chances of finding a date, so one of the best ways to increase our rate of reaction, is by sticking more particles in a given volume. There's much more chance that they are going to bump into each other and be able to react if there's more of them there. There's much more chance that you're going to get a date if you're meeting more people. And so that's exactly what we can do. In liquids, we're increasing the concentration, or in gases, what we're doing is we're increasing the pressure. Remember, gas pressure is just a measure of how many particles there are in a given volume. If you stick more particles in there, then you get higher pressure. But these are basically the same concept in each case. You're sticking more particles in, they've got more chance of bumping into each other, and so they've got more chance of reacting. Next, the speed at which people move around also affects their chances of meeting people. If they're moving very slowly, not much chance of meeting people, but if they're moving quickly, then there's much greater chance of meeting people. And it's exactly the same with particles. The way that we get them to move faster is we increase the temperature. Now this might be the temperature of our solution, or it might be the temperature of our gas, but it's exactly the same process. If you increase that temperature, the particles move around a lot faster and they've got much greater chance of bumping into one another. Next, surface area. I want you to imagine you're at a dance and you're looking out on a dance floor and there are two groups of people who quite want to get to know each other better, but they're in big clumps because they're a bit afraid of going away from their friends and going to talk to that other group. So these two clumps get closer, and maybe the people at either edge of those clumps and around the edges where those two clumps of people bump into each other, well, maybe they're able to get to know each other a bit better and maybe they're able to go off on their own, but it takes quite a while for the people in the middle to be able to get to meet one another. All of those people around the outside have got to meet each other first. And again, exactly the same with particles. If you've got a big clump of some material, then all the particles around the outside have got to react away first before the ones in the middle can react. We can increase the rate of this happening though. What we need to do is split that one big lump up into smaller pieces. So if we chop it in half, what we do is we introduce two brand new surfaces here which weren't exposed before, where we can get a reaction taking place. This is increasing the surface area. If we split it in half again, then we've got even more surface area where the reaction can take place. And again, if we keep dividing and dividing it and split it all up into lots of little individual clumps, then we get a much faster reaction. This idea is one which crops up a lot right across GCSE Science. If you've got a bigger surface area, then reactions tend to happen faster and changes tend to happen faster, no matter what those changes are. So for example, the inside of your lungs has a huge surface area so that it can absorb oxygen from the air much faster. The inside of your intestines has a large surface area so that it can absorb nutrients more quickly. In physics, something which has a larger surface area, for example an African elephant's ears compared to an Indian elephant's ears, something with a larger surface area will radiate out heat much quicker. A really vivid example of how this works is flour. Flour is normally not very combustible. It'll burn a bit if you've got a pile of flour on the table, but not very much. Flour dust in the air, however, can be extremely flammable and even explosive. And that's just because it's got a much bigger surface area. It's exactly the same compound, but if it's got that bigger surface area for air to get to it during a combustion reaction, then that reaction happens much more quickly. Finally, a really crucial concept, which again shows up quite a bit in chemistry and quite a lot in biology as well, and that is the idea of catalysts. Going back to our analogy, this is a bit like giving people somewhere to meet, and that hugely increases the chances of them bumping into one another. Catalysts do the exact same thing. They give our particles somewhere to meet, which increases the chances of them bumping into one another. There's a couple of important things which you need to know about catalysts. Firstly, they are very specific to particular reactions. Each reaction tends to have its own catalyst. Now, in other videos where I mention different catalysts, for example in the enzymes video, you do need to know the names of the catalysts which I mention. In chemistry, when I do a video on the Haber process, again there will be a specific catalyst which you need to know about. But I'm not going to go through listing them all in this video. Focus on the individual videos for that topic and I'll cover them there. The other key thing which you need to know about catalysts is that they are not used up. One reaction can take place on the surface, and once that product has been formed, another two reactants can come along and react on the surface, and so they can be used for that same reaction over and over and over again. Now this is really useful in industrial chemistry because quite often the catalysts are quite expensive to manufacture and quite expensive to use. But because you can keep using that catalyst for that reaction over and over and over again, it actually becomes reasonably economical in the long term. And the thing is, these catalysts speed up the reaction without needing to increase the temperature. So the reaction can happen faster at lower temperatures, and that's really good in industrial chemistry because again, it saves money and it increases the amount of profit you can make. So to recap, all of our ways to increase the rate of reaction rely on increasing the chances of those particles bumping into one another. And there are 4 key ways you can do that. Number 1, what you can do is increase the number of particles in a given volume. In a liquid, you just increase the concentration. In a gas, you increase the pressure. Number 2, you can increase the rate at which those particles are moving around. You can make them move faster. And so all you do to make them move faster is you increase the temperature, you heat it up. Number 3, you can increase the surface area. With a bigger surface area, there's more area for the reaction to take place. Or number 4, you can use a catalyst which gives those particles somewhere to meet. That covers everything which you need to know. And one final point which I'd like to make, and a little bit of good news here, all the different exam boards cover pretty much the same stuff. So this video is suitable for all of the different exam boards in England and Wales. I hope that video really helped you. To see what else I can help you with, there's lots more videos to check out on my channel. Scroll down the main page there to see I've already sorted them into playlists to help you find the video you need. You can also check out my revision guides which cover everything you need to know for the exam. They feature links to my videos, revision tips, cover both foundation and higher tier, and unlike a lot of revision guides, they also point out what you don't need to waste time learning. If you want to check your learning, try the SnapQuiz website and app, which allow you to identify which areas you need to spend the most time learning. Remember, this is the only YouTube channel which brings you the teachers, the textbooks, and the tests all on your terms, on mobile phone, tablet, or computer for you to revise when you want and how you want, even immediately before you go into the exam. All of these links and any others for this video will be down in the description. Lastly, it really does help my channel if you want to leave likes, if you subscribe, or if you know someone else who's having trouble, tell them to search for Mr Thornton. Good luck in your GCSEs everyone, and thanks very much for watching.